Hi everyone. So now that you know about the power rule and how quick we can take the derivative of a function, what are we going to do with it? Well, the main thing that we're going to do with it is we're going to find the equation for the slope of the tangent line, and then we're going to actually find the equation at a given x value. So let's go through this step by step. So first things first, let's take the derivative of our function, which will just be 3x squared. Okay, that's the derivative of the first part, and then minus 3, it's a constant, so the derivative is 0. Okay, and we're going to find the slope of the tangent line at the given x value. So f prime of 2 is 3 times 2 squared, which is 12. That means the slope of the tangent line at x equals 2 is 12. So we're going to hold that, keep it aside for a second. What we're going to need also is the point when x equals 2. So we're just going to drop 2 into this function. We have 2 cubed minus 3, so 8 minus 3, and we calculate that f of 2 is 5. Okay, so that's the 0.25. Anytime we have a point and slope, we can calculate the equation of the line with that point and slope. But what we have to do is we have to calculate the b value. So we're going to take our 12, put it in for slope. We're going to take our 2, put it in for x, and of course the 5 is here, leaving the only variable to be the b value. So we have 5 equals 24 plus b. Subtract, subtract. We get b equals negative 19. So what that tells us is the equation of the tangent line when x equals 2 of this function is y equals 12x minus 19. Now what I'm going to suggest you do, if you're unsure of this, especially when you're doing it on your own, is to go ahead and graph your given function, graph your tangent line, and remember what that should look like. This line should just intersect this function at one point when x equals 2. If it doesn't, you probably made a silly calculation error someplace. So let's go ahead and do the second one. Okay, so again, we're going to go through these steps. So we're going to take the derivative of the given function. Derivative of x squared is just 2x, and that constant, the derivative is 0. In this particular problem, we're trying to calculate the slope of the tangent line when x equals 3. So we've got 2 times 3, which is obviously 6. So that's our slope. We'll tuck it away for a second. Now we need our point when x equals 3. So we have f of 3 equals 3 squared plus 2. Again, just substituting it into our given function. 9 plus 2 is 11. So that is the point 311. So now we have our slope of 6, our point 311. Here we go with y equals mx plus b. We're going to drop our slope in here. Our x value goes in for x, obviously. Y goes in, or 11 goes in for y. And we just have to calculate b. So 18, subtract the 18, we find out that our b value is negative 7, making our equation for the tangent line at x equals 3, y equals 6x minus 7. Yay! Okay, example 3. So hopefully you remember, we might want to do a little rewrite here. Okay, just rewriting our function so that we have x to the 1/2 minus 1. And now we'll go ahead and take the derivative. So we'll get 1/2 x to the negative 1/2. And then again, that minus 1, that's going to drop out because the derivative of the constant is 0. And I think we should do a little rewrite here and bring that x to the denominator, giving us 1 over 2. I would probably write it as the square root of x, but you could have x to the 1/2. It's the same thing. And now we're going to drop that 4 in there. So 1 over 2 times the square root of 4 is just 1 over 2. Oops, 1 over 4. Mistake. So 1 over 4. Okay, we'll tuck that aside. Now we're going to also calculate the point. Like, what is the point when x equals 4? So f of 4 equals the square root of 4 minus 1. So 2 minus 1, that's easy. We get the point 4, 1. Let's take it all and put it all together. Y equals mx plus b. We'll take our 1/4 and put it in for our slope. We'll take our 4, 1, put it in for our point, and we'll calculate our b value. Subtract the 1, we get a b value of 0. So the equation of our tangent line of this function is y equals 1/4 of x. And again, it wouldn't be a bad idea to graph this. Okay, if you think about what your graph would look like, just kind of sketching it out. Let's see. The square root of x minus 1 is just our square root function that has been translated down 1 unit. That's going to look something like this. And our equation of our tangent line is here, y-intercept of 0 and a slope of 1/4. So it's just going to intersect right there in that one spot. Okay, when x equals 4. All right, last one. Why don't you go ahead, why don't you stop the video, take the derivative, calculate f of 2, and then start the video back up and see if you can do that part, and then we'll go into the last part, which is y equals mx plus b. So stop the video and go ahead and do 2/3 of the work. Okay, if you got the thumbs up for these two, then we're ready to go ahead and drop these into our equation of our line. So y equals mx plus b. If you didn't, then obviously you want to go back and see where your mistake is. So we're going to put our negative 1/8 here. We're going to take 2 1/16 here plus b. So we've got a little fraction work. Don't be afraid. Okay, we'll make that negative 1/4. So let's think about this. We have 1/16, and we're going to add the 1/4 to the other side, equals our b value, but I know you know we need common denominators. So we have 4/16 plus 1/16, so our b value is 5/16. So the equation for our tangent line is y equals negative 1/8 x plus 5/16. So now you have a pretty good idea of what we're going to use here with the power rule. Yay! Have a wonderful night, everybody. Bye!